Java contains several sets of pre-written GUI components. These include the Abstract Windows Toolkit, AWT, which components are older and not as portable in the newer frameworks. Swing, whose components are newer than those included in the AWT and are still used in many program environments. JavaFX, which will be studied in Chapter 15, is the newest one. GUI components are also called controls or widgets. Each Swing component is a descendant of J component, which in turn inherits from java.awt.container class. You can insert the statement import javax.swing.*, at the beginning of your Java program files so you can take advantage of all the Swing GUI components and their methods. Almost all Swing components are said to be lightweight components because they are written completely in Java and they don't have to rely on the local operating system code. While some Swing components, such as the J-frames, are known as a heavyweight component because they do require interaction with the local operating system. When you use Swing components, you usually place them in containers. A container is a type of component that holds other components so that you can treat a group of them as a single entity. Containers are defined in the container class. Often, a container takes the form of a window that you can drag, resize, minimize, restore, and close. The container class is also a parent class, and the window class is a child of container. A window is a rectangular container that can hold GUI controls. However, Java programs often prefer to create a frame instead of window. A frame is a window that has a title bar and a border. In Java, frame is a child of window, and a J-frame is the Swing object that is a child of frame. J-frame works like the main window where components like labels, buttons, text fields are added to create a GUI. It has four kinds of constructors. We have a J-frame, no argument, so it constructs a new frame that is initially invisible. J-frame, if we pass a string title, it creates a new, initially invisible frame with a specified title. Then J-frame, we pass graphics configuration parameter. It creates a frame in the specified graphics configuration of a screen device and a blank title. We also have a J-frame. We pass the title and the graphics configuration. It creates a J-frame with a specified title and a specified graphics configuration of a screen device. This table describes some useful J-frame class method. Like a set title, it sets J-frame's title using the string argument. Set size, sets J-frame size in pixels with the width and the height as arguments. And then we also have a set size with passing dimension class object. We have a string get title, so it returns a J-frame title. Then we have a set resizable boolean, so that sets the J-frame to be resizable by passing true or false. If we want the size to be fixed, so we pass false to the method. And the is resizable, it returns true or false to indicate whether the J-frame is resizable or not. Set visible, so sets a J-frame to be visible depending on the boolean we pass in. And the set bounds, so overrides the default behavior for the J-frame to be positioned in the upper left corner of the computer screen desktop. The first two arguments are the horizontal and the vertical position of the J-frame up left corner on the desktop, and the last two arguments set the width and the height. This program declares a J-frame named A-frame, sets its size to 250 pixels horizontally by 100 pixels vertically, and sets its title to display a string. First frame. Pixels are the picture elements or tiny dots of light. that make up the image on your computer monitor. The appearance of JFrame in this figure is provided by the operating system in which the program is running. In this case, we run in the Windows. For example, the coffee cup icon in the frame's title bar and the minimize, restore, and close button look that acts like they do in other Windows applications. So the icon buttons known as Windows decorations. By default, Windows decorations are supplied by the operating system. You can request that Java's look and feel provide different decorations for a frame. A look and feel comprises the element of design, style, and functionality in any user interface. So we can set the JFrame's look and feel using the set default look and feel decoration method. For example, this program shows an application that calls this method. By looking at the program output, you can see Java's look and feel has similar features to that of Windows, but their appearance is different. Java's look and feel is also known by the name Metal. The object of JLabel class is a component for placing text in a container. It is used to display a single line of read-only text. The text can be changed by an application, but the user cannot edit directly. The constructor includes JLabel. Then you pass no argument. It just creates a JLabel instance with no image and with an empty string for the title. If you pass a string as an argument, it creates a JLabel instance with a specified text. If you pass icon, it creates a JLabel instance with a specified image. If you pass string, icon, and the integer for horizontal alignment, it creates a JLabel instance with a specified text, image, in the horizontal alignment. Commonly used method like getText, so it returns the text string that a label displays. We can also set text. We pass the string argument, so the single line of text will be displayed in the label. And we also have a set horizontal alignment, and we pass the integer for the alignment. It sets alignment of the label contents along the x-axis. We also have a getIcon, so it returns the graphic image that the label displays. We also have a getHorizontalAlignment method. It returns the alignment of the label's contents along the x-axis. This program shows an application in which a JFrame is created and its size, visibility, and the close option are set. Then a JLabel1 is created and added to JFrame. Counterpart to the add method is the remove method. So if you want to remove the label from the frame, you can say aframe.remove. Then you pass greeting. If you want to change the value displayed in the greeting JLabel, you can say greeting.setText. Then you pass the new string you want to display in the label. We can change font by using font class. This program gives the JLabel object a new font. We can create a font object as font headline font equal new font Arial font.bold, then 36. To use a font class, you must import java.awt.**. Greetings.setFont headline font will apply the new font to the label. To place multiple components at specified positions in a container so they don't hide each other, you must explicitly use a layout manager, an object that controls component positions. The default layout is a border layout manager. When you use border layout and you don't specify a region, so all the components are placed in the same region and they obscure each other. So when you use a flow layout manager, components don't lie on top of each other. Instead, the flow layout manager places components in rows. After any row is filled, additional components automatically spill into the next row. The Java class provides this type of layout is a flow layout. In this program, a flow layout object is created, aframe.setLayout. So set this layout object. Aframe added two labels. The first one is a hello. The second is who are you. So from the execution, we can see the two labels are set side by side. If we don't set flow layout, the second label, how are you, will be placed on top of hello. So hello disappear is invisible, and you only see who are you. You can instantiate a simple JFrame object within an application's main method or with any other method of any class you write. Alternatively, you can create your own class that descends from the JFrame class. The advantage of creating a child class of JFrame is that you can set the JFrame's property within your object's constructor. Then when you create your JFrame child object, it's automatically endowed with features you have specified, such as a title, size, and default close operation. You already know that you create a child class by using the keyword extend in the class header, followed by the parent class name. You also know that you can call the parent class constructor using the keyword super, and that when you call super method, the call must be the first statement in the constructor. In public class JMyFrame, JMyFrame extends JFrame. JFrame is the parent class. JMyFrame is JFrame's child class. And in the constructor of JMyFrame, the first line is a super myFrame. So this super myFrame actually is called the parent class JFrame's constructor and pass the string argument myFrame. You can also use a set title method here. Then in the constructor of JMyFrame, you can also see we have a set size, set visible, set default close operation. So those are set the property of JMyFrame. And in here, actually we can use this dot set size. So this reference the current JMyFrame instance. Public class create two JMyFrame objects. That's the application that declares two JMyFrame objects. Each had the same set of attributes determined by the JMyFrame constructor. When you execute this application, the two JMyFrame objects are displayed with the second one on top of the first one. And we drag the second JMyFrame on the side, so you can see those two JMyFrame have the same property defined in the constructor, same size, same default close option, same title, etc. The object of a JTextField class is a text component that allows the editing of a single line text. It inherits from JText component class. The commonly used constructors are JTextField, and you pass no argument, though it creates a new text field. If the argument is a string text, it creates a new text field initialized with the specified text. If there are two arguments, the first one is string, the second one is column, that's an integer number of columns. It creates a new text field initialized with the specified text and the columns. If the constructor has an integer, that means it creates a new empty text field with a specified number of columns. We have several methods we can use. The setText method allows you to change the text in a JText field. The getText method allows you to retrieve the string of text in a text field. A JText field is editable by default. If you don't want the user to be able to enter data in a JText field, you can send a boolean to set editable. So if you say set editable and in the round parentheses, you set true, so this text field can be edited. If you send false, it will not be edited. A JButton class is used to create a labeled button that is used to trigger an action or make a selection when the user clicks it. The constructor, if you have no argument, JButton creates a button with no set text. If pass icon, the JButton icon will create a button with an icon of a type icon or image icon. If we pass the string text, the JButton will create a button with text. If we pass a string and pass an icon, so it creates a button with the initial text and an icon of an image or icon. And if we pass the action A, it will create a button in which properties are taken from the action supplied. Action is a Java class. We have a setText method, so the string argument will be passed into setText method. It is used to set specified text on button. We also have a getText method, no argument, and return the string, return the text of the button. In this example, in public class, JFrame with many components, it extends JFrame. Inside the constructor, it first calls the parent class JFrames demonstrating many components. So that will be the title. And also set size, set default close operation. Then it creates JLabel called heading. This heading is this frame has many components. So the label text is this frame has many components. And we set front. Also, the second label, JLabel name prompt equal new JLabel. So that label text is enter your name. And then a JText field is created. There are 12 columns for JText field. Then we have a button, JButton button equal new JButton. And the text is a click to continue. Then we set the layout, new flow layout. So first we add heading. And from the output, you can see the heading is long, so it occupies the first row. Then add the name prompt, the second label. Then add the name field, the JText field. So the label name prompt and the JText field name field, they will be set by side at the second row. Then we add the button. The button is the third row. Public class component demo is the application. So in the main method, an object of a JFrame with many components is instantiated. We see the two labels, and the text field, the user can enter a single line of text. And if you click to continue that button, you can feel like it's a button, but nothing happened because we haven't implemented the actions after the user triggered the button. An event occurs when the user takes action on a component, such as clicking the mouse on a JButton object. So this is an event-driven program. The user might initiate any number of events in any order. Within an event-driven program, a component on which an event is generated is the source of an event. An object that is interested in an event is a listener. So the source triggers an event or files an event. If you want an object to be a listener for an event, you must register or sign up the object as a listener for the source. To respond to user events within any class we create, the first step is to prepare our class to accept event messages. Java.awt.event packages include event classes that provide the capability to work with user-generated events. So we need to import java.awt.event. You import the event package to gain access to the methods in the event classes. And then you prepare a class to work with events by adding an implements phase to the class header. For example, implement the action listener interface provided you with standard event method specifications that allow a listener to work with action events. The next step is to tell your class to expect events to happen. The method that registers an action event is addActionListener method. In this example, press me is a button. So we say press me dot addActionListener. Then we pass this as an argument. This statement calls any action event messages. In this case, the button clicks. Comes from press me button to be sent to the frame. The argument this reference this current object. So in this case, this refers to the frame class in which this statement appears. The third step is to tell your class how to respond to event. The action listener interface contains the action performed method specification that executes when event occurs. This method is an example of an event handler. It reacts to and takes care of general events. When you implement the action listener interface, you must write the action performed method to overload the empty version in the interface. In this example, the action performed method, first we have a string name equal answers.getText. So answer we declared as a JText field object. The name will be assigned for the text entered into the JText field. Then we have a string greet equal hello, then concatenate with the name. Then the greeting is declared as a label, so JLabel will show the text in the greet. So that basically is the hello. You concatenate with the contents in the JText field. This JHello demo is the application to instantiate the object of a JHello frame class. So in the main function, we see JHello frame, then frame equal new JHello frame. The JHello frame object named frame is instantiated. Then we set the visible to 2. And from the output, we can see if we type the name as Mary and we click press me, which is a button, the string hello, Mary will be displayed in the label. You can add more than one event source component to a listener. For example, you can say press me is a button, press me.addActionListener this. You can also call answer, which is a JText field. You say answer.addActionListener this. In the action performed method, we know we have an argument, which is an action event E. So action event E, this E, we can use the method e.getSource. So it will return which object is the source. For example, in this class, if we have two J buttons named as option 1 and option 2, then in the action performed method, we can say object source equal e.getSource. So it will return which source. And if source equal, so if source is from option 1, we execute those statements. Otherwise, we execute other statements. So the Boolean source equal, the name of the object, can identify the exact source. You can also use the instance of keyword to determine the source, but the instance of keyword is used when it's necessary to know only the component's type, not the exact component. So we say if source instance of JText field, if the source is one component and the type is JText field. If you have a multiple JText field register with action listener, it cannot determine which exactly JText field object is. setEnable method allows the user to make a component disabled or unusable, or enabled and usable. You can use the setEnabled method to make a component available or unavailable by passing true or false to it. So for a text field, what is the difference between set editable false and the set enabled false? The text fields are editable by default. The code set editable false make the text field uneditable. It is still selectable and the user can copy data from it, but the user cannot change the text field contents directly. The code set enabled false disabled this text field. It is not selectable and the user cannot copy data from it, and the user cannot change the text field contents directly. Many types of listeners exist in Java, and each of these listeners can handle a specific event type. A class can implement as many event listeners as it needs. For example, a class might need to respond to both a mouse button press and a keyboard key press. So you might implement both action listener and the key listener interfaces. In this table, it lists some event listeners and the type of events for which they are used. For example, we have an action listener. The type of event is an action events, like a button clicks. We have an adjustment listener. Adjustment events, like a scroll bar moves. We have a change listener. That's a change events, like the slider is repositioned. We have a focus listener, which is a keyboard focus event. And for example, we have a text field gains or loses focus. We have an item listener, that's an item event, like a checkbox, we change its status. We have a key listener, which is a keyboard event, like the text is entered. Mouse listener, mouse events, the mouse clicks. Mouse emotion listener, mouse movement events, the mouse rolls. We also have a window listener, which is a window events, we close the window. We already know that we can establish a relation between a J button and a J frame that contains it by using addActionListener method. Similarly, we can create relationships between other Swing components and the classes that react to users' manipulations of them. So in this table, each component listed on the left is associated with the method on the right. For example, when you want a J checkbox respond to user's click, you can use addItemListener method to register the J checkbox as a type of object that can create item event. The argument you place within the parentheses of the call to addItemListener method is the object that should respond to the event. You must perform those steps to declare a class that handles an event. First of all, you must import java.awt.event package in a class that handles the event. Then the class that handles an event must either implement a listener interface or extend a class that implements a listener interface. Then you must register each instance of event handling class as a listener for one or more components using an addListener method. So we have a multiple addListener method listed in table 14-2 in page 734. Then we must write an event handler method with appropriate identifier that accepts the generated event and reacts to it. And those methods are listed in table 14-4 on page 735. For addActionListener, we have an actionPerformed method we have seen in previous example. For adjustmentListener, we have an adjustmentValueChanged method. For focusListener, we have a focusGained and a focusLost method. For itemListener, we have an itemStateChanged method. The JCheckbox class is used to create a checkbox. It is used to turn an option on, which is true, or off, which is stand for false. Clicking on a checkbox changes its state from on to off, or from off to on. In this example, we created 4 objects of a JCheckbox: coffee, cola, milk, and water. And we add action listener by, remember for the checkbox, we have a user add item listener, right? So coffee dot add item listener, cola dot add item listener. For the checkbox, we have an item state changed method. So in case the checkbox is clicked, what happened? Right here in this example, actions haven't been implemented. The main method is included in this class. So in the main method, the checkbox demonstration object is instantiated. For the checkbox, we can have the set text method. So you pass a string, so the label of the checkbox will be changed. We also have a set selected, and you pass a boolean. If you pass true, the checkbox will be checked. If you pass false, the checkbox will be unchecked. We have a isSelect method. It will return the status if the checkbox is checked or not. The constructor for JCheckbox is if you pass no argument, it creates an initially unselected checkbox button with no text, no icon. If you pass the string S, it creates an initially unselected checkbox with text. If you pass the string and the boolean value, so it will create a checkbox with text and specify whether or not it is initially selected. So you want the JTextBox initially checked, you pass true. If you want to unchecked, you just pass false for the second parameter. Sometimes you want options to be mutually exclusive. That is, you want the user to be able to select only one of several choices. When you create a button group using the button group class, you can group several components, such as the JCheckboxes, so a user can select only one at a time. When you group JCheckbox objects, all of the other JCheckbox objects are automatically turned off when the user selects any one checkbox. To create a button group in a JFrame and then add a JCheckbox, you perform the 4th step. First one, you create a button group, such as button group A group equal new button group. Then you create a JCheckbox, such as a JCheckbox A box equal new JCheckbox. Then you add A box to A group with A group dot add, then A box. Then you add A box to the JFrame with add A box. Or you can use this reference. You say this dot add A box. JButton is a swing component that represents an item with a state selected or unselected. Usually a group of radio buttons is created to provide options to the user, but only one option can be selected at a time. In this program, 3 JRadio buttons are created. Their name is option 1, option 2, and option 3. So for the constructor, we also pass the text for the label of the radios. We pass Linux, Windows, and Macintosh. Then a button group is created. So button group equal new button group. Then group dot add option 1, group dot add option 2, group dot add option 3. So we add those radio buttons to the button group. Then we set the layout, and we have an add option 1, add option 2, and add option 3. So those are add radio buttons to the JFrame. JComboBox is a part of a Java Swing package. JComboBox inherits JComponent class. JComboBox shows a pop-up menu that shows a list, and the user can select an option from that specified list. JComboBox can be editable or read-only depending on the choice of the programmer. You can construct a JComboBox using an array of objects at the constructor argument. The objects in the array become the list items within J combo box. For example, string array, major array equal English, math, sociology. Then in J combo box, major choice equal new J combo box. And for the constructor, we pass major array. This table lists some methods we can use with the J combo box object. For example, we can use set selected item method or set selected index method to choose one of the items in a J combo box to be the initially select item. You can also use the get select item or get select the index method to discover which item is currently selected. The list of items in a J combo box object is an array. So the first item is at position 0, so the index starts from 0. In this example, we first create a JFrame object. We say f equal new JFrame. The title is a combo box example. And we define a string array country which has India, Aus, USA, England, and New Zealand. Then we create a J combo box CB equal new J combo box. Then we pass the country, which is a string array, cb.setBound, and we pass 4 arguments. The setBound method is used to set the position and the size to specify the position and the size of the components manually. It needs 4 arguments. The first 2 arguments are x and y coordinates of the top left corner of the component. The third argument is the width of the component, and the fourth argument is the height of the component. So here we set the location of the J combo box, and we use f.addCB. So we add this J combo box to the J frame. So from the output, you can see this J combo box contains the list of elements in country array.